Okay, so for those of you that'll be tuning in maybe a little later, or they're going to start working on this next problem set, okay, one of the aspects that we want you to start thinking about is with each and every problem, regardless, two things are going to be in common. One, you must have what? Do we remember? You have to have some sort of chemical equation or a reaction. And two, at some point, you need to be dealing with a gas, either starting with a gas and converting to a solid, or starting with a solid and converting to a gas. That's why it says, of course, as you can see, gas stoichiometry. So number one was selected. Bromine reacts with 5.60 times 10 to the, you could say, third or cubed power of cubic centimeters hydrogen to yield what mass of hydrogen bromide at STP. And when you look at a lot of these problems, the first four are at STP, but then number 5, which is a little more difficult, okay? And that would be because it's a gas that's not measured at STP, but you are given the needed amount of information to solve for that. But regardless, number 1 was picked. So it says bromine. So what do we write down for that? Okay. It says it reacts with hydrogen. So what do we want for hydrogen? Okay. And then yields what? Hydrogen bromide, correct? Okay. Is that it? If you did not do that, okay, perhaps not putting that 2 there, any work you did beyond that would be probably wrong, okay? It's not meant to be mean, okay? It's just meant to, okay, if it's a mistake, 2 things. 1, try to learn from your mistakes. 2, try not to repeat them. So what are we starting with? 5,600 milliliters of what? Okay, so different ways you can write that. You could say, and we'll balance that in a moment. You could say 5.60 times 10 to the cubed of cubic centimeters, which is the same as a milliliter. Or if you want to change that to a whole number right away, what can you do? Write it as a whole number as 5,600. Okay, that's milliliters. But when we are dealing with gases, they must be in what? Okay, they must be in liters. Okay, and maybe you said that, but I'm not going to acknowledge someone who is lip syncing. Okay, all right, so change it to liters. How do we do that? Okay, so we can get rid of this. You say divide by 1,000. That's what we're doing. Move it to the left 3 times. So we got 5.6 liters. Okay, and then what's the question ultimately asking? So X amount of grams of hydrogen bromide. Okay. So keep in mind, this is just the first problem, and I don't know if it's true for every type of paper that you'd work on with, whether it's well, it can't be pre-calculus because you'd be down there, okay, because it's this hour. Whether it was Algebra 1, Geometry, Algebra 2, is it accurate that maybe the first few problems, or the first one, should be the easiest? Is that a rule of thumb, maybe? I don't know if we believe that or not, but it's not meant to be perhaps intimidating. But with this, what's the next thing we need to do? You said a reaction. We've got our reaction. Got a place to start, but we got to do one more critical thing before we can proceed. Okay? We need to balance that. Okay? So pretty simple. Just need a 2 here. Okay? we've just done some brief amounts of just straight up dimensional analysis. I think, is it pretty fair to say that I don't want to deal with it? I just want the ideal gas law only. There's one, actually. 2, 3, okay. All right, that's everybody. No one does straight up dimensional analysis? It is a lot easier. But maybe it's more confusing. Is that why you don't want to approach it that way? Is that fair to say? I mean, that's fine. Okay, so if we are doing the ideal gas law, what do we know in this problem? I'm going to trip over this thing yet. Okay? Well, what's the temperature, though? Just tell us so we'll all know. 273. Okay? Do we? Say that again. Why is that significant? It is significant, but why is that? That's our volume. Okay? So what is our unknown then? Okay, so we do not know what that is. Okay? Because as you correctly said, N stands for what? We need to find our number of moles. Okay? Because once we solve that in moles of hydrogen, then we can do what? Convert that moles of hydrogen into what? Yeah, grams of hydrogen bromide. That's right. Okay, so some of you, I've noticed on some of your papers, we're getting ahead of ourselves and saying that. That's fine, okay? You're putting those two together and saying that's 22.4. But if we're looking at this as an equation, okay, that means we've got 5.60. Our pressure is over here, but do we need to account for that mathematically? No. Why not? You're right. It's just one. You're just going to get 5.6 anyway. Okay? This stuff is hard enough already without having to try to make it more difficult. So we know that on the right-hand side, we've got N, we've got R, and we've got T. Okay? So then if we've already accounted for R and T, and we're looking for N, you can take a shortcut and just write this, correct? Agreed? Please tell me if this confuses you. Say, I'm confused, otherwise this is really going to be not fun for you. I'm not saying that to be mean. I'm just pointing out how it is. Okay? And for those of us who are tuning in, okay, in short, pressure, volume, N, R, and T. We've accounted for our volume. Our pressure was just 1, so you multiply that by 1, you're still going to get 5.6. If we take 0.0821 times 273, like this equation tells us to, that's what we're accounting for here, you're going to get 22.4, and we've got this variable left. Okay? So that means we've got to get N by itself now, which means use your algebraic skills. Okay? Dividing each side by 22.4, N is going to be what? Now, when you're doing this, I would suggest don't just write it like this, because if you get interrupted, like I like making fun of you people all the time. What do you think I'm getting at when it comes to making fun of you and you get interrupted by these things that are sitting on your desk now? Not everybody. I see one, two, three, four. I mean, and that's fine. But you're going to get your silly Snapchats or whatever. You can get to this point, and then, oh gosh, I got to check that out. Or are some of you disciplined enough to say, I can't look at my phone, I've got to do this first? Right. We got one? Come on, I got to hear two. Get in on this auction here. I hear one, two. Let's go for three. Do I hear three? Three. The two. Okay. This is where people's noses are getting longer. They're experiencing warmth in their trousers area as liar, pants are on fire. Okay? Okay? All right. But what are we getting at? 0.25 moles of what? Hydrogen. If you do this, you are just only going to be confusing yourself. Okay? And I didn't do that right, did I? But I know what that means. I don't know if you know what that means, though. Moles of hydrogen. Okay? Now you're in familiar territory. Okay? Now you can convert moles of this substance into grams of this. Okay? So now we've got 0.25 moles of hydrogen, okay? Even though you're not looking for a mass of this, okay? I've noticed on a lot of your papers, it's just human nature, I know. But if we were looking for a mass of this, why are people going to be off by a factor of 2? Because they only put moles of hydrogen instead of moles of hydrogen 2. You're going to be off by a half, or if you want to say a factor of 2, if that makes sense. Now we've got moles of hydrogen. Now we can get to the other side of the reaction. And how do we do that? We got to get from moles of this substance into moles of this and ultimately grams, but we got to do that in a specific manner. Okay, so for moles of H2, what can we put on top? Okay, remember, this step allows us to change what we have into what we're looking for. Here's what we have. This is what we're looking for. Okay, and then there's something very specific about this step. Your mole to mole ratio. Why is that important? You're right. But why are you right? But yeah, yes, everything you're saying is true. But you got to look back at your equation. Why? Close. Okay? When these numbers, 1, 1, 2, are important for a reason. So that 2 written in a black marker is important. Why is that? That's correct. It has to go into here. Okay? Then these have canceled. We're in moles of hydrogen bromide, but we want grams of this, not moles. So our final step is what? So for every mole of hydrogen bromide, what can we put up top now? Grams of hydrogen bromide. Bromide, is that bromine? Is that 79? So 80, 80 or 81? Okay, 81. Okay. Then, again, don't do this. People are going to do this. Now, again, you ladies and gentlemen laugh, but this happens. Why would someone possibly put a 2 here? For one, it doesn't belong there, because in this step it is not a what? Yeah, it's not a mole-to-mole ratio. So that 2 can't be in there. Now we've got everything canceling out. We're in grams of hydrogen bromide, and that's what we're looking for. All right. Yes, sir?
Is antimony diatomic?
No. Antimony is not diatomic. Okay. So rut row, are we on the bus? Second row, are we on the bus? Third row, are we on the bus? Okay, I saw everyone doing this. You are telling me you understand this? That's great. Okay, so that's all I have. The rest of the time then is yours. We'll catch up to you next time.